Comilla, Higher Maths 2017, Question 3. Consider the following infinite series: 1 plus 1 over 1 plus 3x plus 1 over 1 plus 3x all squared plus 1 over 1 plus 3x all cubed. In part A, we have to find the common ratio of the obtained series when x equals 1. Well, if we look at the series when x is 1, the first term is 1, the next term is 1 over 1 plus 3, or 1 over 4. The term after is 1 over 4 squared, which is 1 over 16, and the next term will be 1 over 4 cubed, which is 1 over 64. The common ratio is the second term divided by the first term, so it's a quarter divided by 1, which is a quarter. In part B, we have to find the sum of the first 10 terms of the series obtained when x is a third. Well, if x is a third, the series is 1 plus 1 over 1 plus 3 times a third, that's 1 over 2, plus 1 over 1 plus 3 times a third squared, that's 1 over 2 squared, or 1 over 4, and so on. So the series is 1 plus a half plus a quarter, and so on. Now again, the common ratio is the second term divided by the first, so it's a half divided by 1, so it's a half. Now we can use the formula for the sum of the first n terms as the sum of the first n terms, Sn, is equal to a into 1 minus r to the n divided by 1 minus r. And we have the first term is 1, and the common ratio r is a half. So S10, the sum of the first 10 terms, is equal to 1 times, and in brackets, 1 minus a half to the power 10, divided by 1 minus a half. Now if we divide by a half, that is the same as multiplying by 2. So S10 is equal to 2 times, and in the bracket we've got 1 minus 1 over 2 to the 10. Now that can be written, the sum of the first 10 terms, S10, is equal to 2 into, in the bracket, 2 to the 10 minus 1 all over 2 to the 10. Now the 2 outside the bracket cancels with one of the 2's on the bottom, so we have S10 is equal to 2 to the 10 minus 1 over 2 to the 9. Well, 2 to the 10 is 1024, so we have the sum of the first 10 terms is 1023 divided by 512. Now in part C, we're asked to find the condition which should be imposed on x so that the given series will have a sum up to infinity. Now the common ratio is 1 over 1 plus 3x. And for the series to have a sum to infinity, that must lie between minus 1 and 1. So minus 1 is less than 1 over 1 plus 3x, which is less than 1. Now what we want to do is get rid of the fraction by multiplying by 1 plus 3x. The problem there is that if 1 plus 3x is negative, you have to change the direction of the inequalities. So if we first of all assume 1 plus 3x is greater than 0, that is, we assume 3x is greater than minus 1, or x is greater than minus a third, then we can multiply all sides by 1 plus 3x and not change the direction of the inequalities. So that gives us minus 1 into 1 plus 3x is less than 1, which is less than 1 times 1 plus 3x. Now that means minus 1 minus 3x is less than 1, and also 1 is less than 1 plus 3x. That can be rearranged as minus 2 is less than 3x, and 0 is less than 3x, which is the same as saying x is greater than minus 2/3 and x is greater than 0. So we have three possibilities: x is greater than minus a third, x is greater than minus 2/3, and x is greater than 0. Well, they will all be true only if x is greater than 0. Now the other possibility is that 1 plus 3x is negative, it's less than 0. In other words, 3x is less than minus 1, or x is less than minus a third. In that case, when we multiply by 1 plus 3x, the direction of the inequalities changes. So, minus 1 into 1 plus 3x is greater than 1, which is greater than 1 into 1 plus 3x. Now they can be simplified as minus 1 minus 3x is greater than 1, and 1 is greater than 1 plus 3x. If we subtract 1, we get minus 2 is greater than 3x, and 0 is greater than 3x, which is the same as 3x is less than minus 2, and 3x is less than 0. So x is less than minus 2/3, and x is less than 0. So there we have three situations. X is less than minus a third, x is less than minus 2/3, and x is less than 0. Well, for them all to be true, x must be less than minus 2/3. So we have, as a final condition for x is less than minus 2/3, or x is greater than 0. If you actually draw the graph of y equals 1 over 1 plus 3x, we can see it, and we're looking for the part where the graph lies between y is 1 and y is minus 1. Now that's the unshaded part on the graph. And we can see that the values of x for which the graph lies in the unshaded region are either x is less than minus 2/3 or x is greater than 0. Now finally, we're not asked for the sum to infinity, but if we wanted to work it out, the sum to infinity is equal to a over 1 minus r. So in this case, the sum to infinity is 1 over 1 minus 1 over 1 plus 3x. If we multiply top and bottom by 1 plus 3x, this simplifies to 1 plus 3x over 1 plus 3x minus 1. So the sum to infinity is 1 plus 3x over 3x.